Cool. So we'll read this quickly and then we'll discuss. Cool. Meta discussion is pretty nice.
कुछ भी नहीं दे रखा.
It gives you the context on why, where consistent hashing comes from, why it is important, where it is used.
अरे इससे एक एग्जांपल दिया उन्होंने, उससे पहले तो मतलब वो नाम का ही बता रहा था. ठीक है, वो ट्राइफेक्टा बता दिया उन्होंने.
It has given multiple examples. इसने बोला Akamai uses it heavily.
कमाई दे रखा है और क्या दे दिया, वो डायनामो दे दिया,
Correct.
बिटटॉरेंट का बता रखा है.
हाँ तो this is good enough for the people who, for the
ठीक है.
uninitiated, this is good information. Did you know Akamai uses it?
कमाई नहीं है, मेरे को नहीं पता था. ऑब्वियस ये पता है बस कि भाई वो कई तरह की तरह सीडीएन में है, बट ये नहीं पता था मुझे कमाई का.
But any web system, right, where we need routing across multiple servers, will be doing hashing or some sort of things.
Where
हैशिंग कर रही है, बट नॉट नेसेसरली कंसिस्टेंट हैशिंग ना.
no, if any system where you need balanced distribution of traffic will need consistent hashing.
आप जो कह रहे हो that is right, but my question is, apart from consistent hashing, is there no way that we can do, मतलब if you guys know, is consistent hashing, before consistent hashing there was no balancing in any form.
There was balancing, it was not required. So consistent, well, if you look at it, right, if you read
That is what it says as well.
It was not required. And this, any problem, you cannot say that statement cannot be made for any algorithm, in my opinion.
Okay.
That is the only algorithm to solve a specific problem, and that's not how we look at the problems or the solutions as well.
Agree. I'm asking for the understanding.
So you can achieve it for depending upon your use case. You maybe use a tweaked version of this, or you may for you probably just simple hashing may work out. For example, if you're doing MySQL sharding and you're doing it based on the company key that you are working with, maybe hundreds of companies, and you are sharding basis on the company's data, then you don't need consistent hashing. You can just have company key as a company key and the server as the hash function, and you are done. You are mostly sorted over there.
Correct. ठीक है.
This is for a highly distributed system for very high kind of a traffic.
ठीक है. Got it.
For a general purpose system, this will help.
Simple load balancer example also, right? Well, there are multiple approaches, but one of them could be consistent hashing to route to your underlying system.
Correct.
हाँ, ये था कि basically consistent hashing is not specifically used in caching. It is major purposes for routing to either to cache server, either to distribution, equal distribution as much as possible.
Yeah, instead of routing, you call it distribution. It makes it slightly more generic.
नहीं, आप distribution कह लो, but reality में if you look at a core level, right, it is in the end doing routing only. It is ensuring that a routing is equal.
For your use case, for the use case that we are discussing, it is routing, but you may use it for distributing of the requests or distribution of the data.
Let's take an example in which case it is distribution of data. Let's just
in this example, wherever we are talking about it, where there's a request involved and there's a data which is a
correct.
Context has both the request and the data.
Correct.
right? If you had to redistribute, let's say you have a huge file system and you want to, and you have hundreds of disks, and you wanted to distribute the data across all the disks, you would still use consistent hashing to distribute the data, but there's no routing.
The
No,
routing is because consistent hashing is identifying where the data is going.
I think it's
Routing is not happening because there's no request.
In my opinion, if I look at a very basic level, layman terms, it seems it just tells a single server tells okay where it should go. That server can be anything, okay, and that is where the consistent hashing is happening, and that's in it's telling okay you should go to this server, you should go to this server, you should go to this server on the basis of what the outcome of the hash is.
You are right in the context of web request, in the context of request response system, client server model, you are right. If you remove the client server component, request response over there, and you just have some data that needs to be distributed, where does routing come?
Data you just
the
have
term
some
you want to talk about is not routing, it's more about mapping. Like you're mapping a particular object to underlying your list of things.
Correct.
That could be anything. It could be a server serving a request, it could be a server storing the data, it could be anything.
Mapping would be the right term in that.
Yes, correct.
Mapping would be right, I think. Mapping, because mapping covers both the part. Okay.
So should we move to the web caching?
I'm reading that.
Are you guys done with the 1.3 and 1.2?
I'm reading 1.4.
Perfect.
Yeah. Starting.
Nice. I didn't know we can implement a consistent hash using RedBlack tree.
अभी तक वहाँ पहुंचा ही नहीं. Can we get a visualization of red-black tree, the consistent hashing using red-black tree? That would be really nice.
I think it should be available. Let me search for that.
Because I really want to see it. I don't know how it. I don't really know much about red-black. Only that it is balanced.
RedBlack, you should be able to first you understand RedBlack tree. And
No, I
then
know what a red-black tree is. I don't think I have ever implemented it.
a second. Try this.
I mean the visualization of consistent hashing using. Achha, it is hashing. One sec, I'll check it. Well expected.
Can you done?
Variance, well, I didn't get much, but
Variance, that same thing, if you remember.
It's implemented in Dynamo, no?
Dynamo में we saw that, right? How do you
Replication factor.
not replication factor? Dynamo में we saw that even with consistent hashing, it's possible that some of the nodes get higher traffic than the other nodes. So that is a variance. How much data is getting mapped to the topmost, the hottest node versus the average. तो उसको reduce करने के लिए we discuss they implement something called token based algorithm, right? Which is just another way of saying having high number of virtual nodes for every server.
conceptually I understand, but I haven't fully understood this K implementation. Like you have K hash functions and how it is using those K hash functions to enforce the equal distribution.
Those K hash functions are basically K each cache is. K virtual for each cache.
I understand. I think I got it now.
Hmm.
Basically, what they are doing is one hash function will hash your servers onto the ring in one way. And the logic of storing is like basically you store all the keys that are left to you until you find another server, right? Then basically every key is part of 4 servers. So it is getting replicated to 4 servers, but let's say assuming 4 different hash functions, eventually you will have like let's say because of hash function 1, let's say one node was having only 5 keys out of 10,000, but because of the other hash function it will be storing, let's say, much more. So effectively more the number of hash functions, it will be eventually get equally distributed. So let's say if you have number of hash functions equal to total number of keys, effectively you are storing all keys on all the servers.
But over here also they're doing double level of hashing then, right?
They are doing 4, like in this example, they are doing 4 hash functions on 3 servers. So
Yes. So one for addition of one object, only one of these hash functions will be used.
I think they are using all four.
No, so नीचे देखो, by symmetry, each cache still expects to get 1/nth fraction of the objects.
The replication increases the number of keys stored in the balanced binary tree search by a factor of k. So
My question is it replication or is it basically is the cache making 4 copies, or is it that just to ensure that there is an equal distribution, they're making those virtual copies, and any data, any key before that goes to that copy of cache. So let's take this example. No, this figure. Can you scroll down?
So just let me reread this one, right? So you have 3 server S0, S1, S2, and k is equals to 4 hash functions. So it gives you hash function 1 of server and hash function k of server. It says 4 labeled 0, 4 labeled 1, and 4 labeled 2. So basically what it does is, so from the
S0 is 4.
hash function 1, you have S0, S1, S2. Now these could be any, like, so you get 4 S0s, 4 S1s,
Correct.
4 S2s. These corresponds to 4 different hash functions.
No, these do not correspond to 4 different hash function.
They do.
No, so but
we choose 12 points on the circle, 4 labeled 0, 4 labeled 1, and 4 labeled 2.
4 labeled 2.
Objects are assigned as before. From HX, we scan rightward clockwise until we encounter one of the hash function values of some cache S, and S is the responsible for storing S by symmetry. Each function will.
So it is only this is where it gets confusing, right? Over there they are saying they're using 4 k hash functions, and over here they're not at all saying for storing, they're saying they only use 1 hash function.
No, they are using 4 hash functions. What they are doing is, let's start from 0. So 0 to this S0 is storing, S0 to S1 is storing, then S1 to this S2 is storing, S1 to S1 is storing, S1 to 2 this S2 is storing. So what they have done is they have created 12 points on the hash on the ring rather than only 3 points. So let's say if you're using 1 hash function, how many total points will be there on the ring except the keys? 3, right? S0, S1, S2.
So you are basically saying that to create those virtual points, what they have done is they have used 4 hash functions,
right?
Only to create those virtual points, but to store the data.
To store they are using all these 12
only
points.
1 hash function.
No, they're using all hash functions.
How? If they're using 4 hash function, that means there will be 4 copies.
No, there's no concept of copies. For now, what they are doing is, okay, let me try to explain, right? See what, so let's go to the previous ring. In a normal scenario, what is happening is, let's forget S3 for now. Okay, we are saying there are 3 servers only. So in this normal scenario,
No, let's take this now. Let's take the left one. Let's take the left side.
Yeah,
so
anyone. So what they are doing is, first, this is your key ring.
Correct.
All the keys are hashed here. Now you hash the servers also onto the same ring.
Correct.
Now it says that, like, all these keys are assigned to S1. All these keys are assigned to S0.
Correct.
You can see it's not in order. It's out of order also, because S0 was hashed here and S1 is hashed here.
That's fine. Correct.
These are assigned to S2, and then these are assigned to S1. Right? Correct. Now, the problem with this approach could be that there's no equal distribution. It could be that S1 is here, S0 is here, and S2 is here. Then everything from here to here is part of S1.
Correct.
All this problem, what they are saying is they have used 4 hash functions.
Correct.
Now, 4 hash functions will hash this S0, S1, S2 at different places on the ring. So total you get 12 points.
Correct.
So they have drawn this 12 points onto this ring.
Correct.
What they are saying is this range belongs to S0. Now S0 has 4 ranges as compared to only one range. This range belongs to S0. This range belongs to S0. This again belongs to S0. This belongs to S0. So this is the total range of S0. Similarly for S1, S2, and so now they are saying that if we more the number of hash functions, more symmetric it will be, because like error of one hash functions will be covered by the other hash function.
Absolutely. What I'm saying over here is that every single time for data, the hash of the data will only be created only using one hash function. Will not be created using 4 hash functions. The 4 hash functions was to ensure the randomization of the virtual points on the ring. So the figure which we saw earlier, right? That was using the hash function 1. Now using the hash function 2, it will give some other points. Then third will give some other point.
Data, like let's say, how do I compute?
See, over here, this says the object are assigned as before. From hx, we scan rightwards and then we put. So it is only one hash function for assignment.
Right, you're right. So basically, there was only one function used to hash hx, but there are 12 points created using 4 h1, h2,
4
h3.
hash function.
Yeah, Baljit.
Wait, I just read it in, completely again. So they're using more hash functions just to allocate the server a different value on the hash ring.
But also, I think this clarifies.
But k is equal to log.
K is equals to log n.
Reasonably balanced loads. Yeah. If number of nodes is 4, then log 2 is 2. K of 2 is reasonably, so they're saying K's value of 2 is good enough for 2 server node. Just having 2 virtual nodes is good enough. Reasonably, that doesn't sound right.
Intuitively, it doesn't.
Yes. For higher loads, definitely not.
But they are also saying, right, like choosing k approximately log n is large enough to obtain reasonably balanced loads. That is the max. See, 1 is definitely bad. As we keep on increasing, we will find some balance, and log n we'll find is large. It's too good.
Take it. If we use this logic, though, the number of nodes in the ring will increase exponentially.
Why exponentially? It's number of servers, right? Like if you have n number of servers, then not servers. N is your total.
You're saying the multiplication factor is should be equal to log n. Right?
Okay.
So the moment you increase n, the value of k that needs to be multiplied increases by logarithm, right?
Not
value of n is being kept constant here. I think we are not increasing n here.
No, it can increase, right? Consistent. That's the whole point of consistent hashing. No, we
n
will
is
increase.
N is your total
it is
key
not.
space.
Sorry. It's not exponential. It is n log n. It is.
It's logarithmic.
N log n.
But
it is not increasing because your total key space is constant here.
Only the key space is constant. Also the server is constant, but what I think Baljit is saying that for the timing, let's say n is equal to 2, there are only 2 servers. So the k can, they're saying it is okay if you keep the multiplier as 1. You do not keep basically any virtual node at that time.
I was looking at this one, the last sentence of this section, right? The sensible approach is to make number of virtual copies of a cache server proportional to the server capacity. For example, if one cache is twice as big as another, it should have twice as many virtual nodes.
Where is it?
Just scroll down a bit.
1.4, last sentence.
Scroll down. Seventh page. Over here. That's it. That's it.
But I get it. This is not what I thought.
But I think one confusion Vivek has is n is not the number of nodes. N is the total key space.
N is not the key space.
N is the key space.
Wait.
The key space.
Where n is the number of caches.
Is it?
The number of caches are the systems.
Number of caches is the number of systems. Number of
servers.
Nodes, number of server nodes. Yeah.
Yeah.
It is there on page number 6, just before reducing the variance.
Number of caches.
Yes.
But S was number of servers, right?
No, S is the name of the server.
Name of the server, yeah. S0, S1, S2.
Your this 0 to 32 minus 1 is your n, right?
No,
Yes.
this is your range.
No. That is
This is
your
your
hash
range.
space.
Hash space. This is your hash space, correct.
Malab, in the beginning itself, in the consistent hashing, the first sentence it defines. We want hash table functionality to add with additional property that almost all objects stay assigned to the same cache, even as number n of caches changes. Okay.
Pretty straightforward though. I think but this is something which seems a bit difficult, but once you read and once you understand the basic thing, I think it becomes quite easy.
I think there's slightly a little bit of mathematical terminologies was slightly confusing. It needed a little bit of reread.
I think what probably we need to do a deep dive on sort of would be to what a hash function would be, because a lot of people understand MD5 and SHA-1, but they don't understand how it is converted to an integer. Even I did not initially.
It is not getting converted to integer.
It has to convert it to integer to get a value on the hash space, because the hashing space is basically the starting from 0 to the highest value of integer, that is 2 to the power 32 minus 1. Not the highest value of integer, it can be more than that, but this is what they are taking, so it is an integer.
A second. That's just an I think this is just an example, right?
More or less that's how they are doing, right? They have to convert the hex value to an integer to actually get that on the hash space, else it is going to be difficult from what I understand. And on this, I think one of the things which I learned was definitely this virtual node. Although we read it in Dynamo, but I did not know that it is actually a part of consistent hashing variation. I would like to definitely see a visualization of how consistent hashing is implemented using RedBlack. That would be cool.
The RedBlack tree is used only for finding the server where the data has to go.
No, that's what I want to understand. How is it? So how the values are going to get stored in RedBlack tree? What values are going to get stored over there?
So it's not going to be different from any other RedBlack tree. There's nothing magical happening which is related to consistent hashing over there.
I'm not saying that there's something magical happening. I'm only saying what values are going to get stored in RedBlack.
Yeah, hashed values.
Hashed values are going to get stored over there.
Or just only server nodes.
That is the point right now. If there's a server node, how is it finding where should I store the value? If let's say I have an object of which an hash comes out, how should I know where it is going to get stored?
That's why they're using RedBlack tree, because it exposes a method called the successor of a node.
Successor of a node. Oh, so it tells you that if you are given a node, then what is the next node after this?
Correct.
Perfect.
But you will create the RedBlack tree using the hash value, but in the node you can also put metadata like this is server 2, let's say. But the hash value is getting used to create
Basically, what we are
the
saying
actual
is,
tree.
basically what we are saying is every server will have a hash value, which will, for the sake of simplicity, let's say the hash value is an integer. It is getting stored in a balanced way in RedBlack, and each node has some metadata which will tell you what server it is, what etc. etc. Okay, or the path or the URL, whatever it is. And then I do not know that there is a successor method. So every time an object comes to you, you basically take an object, you hash it, you get an integer value. Using that integer value, you can find the successor of that integer value and then get the server details from there.
We can show that. Sunny, I've shared that link, right? If you open that.
So there's no pre-existing function kind of thing. It's like something you can implement. They have
I
terminology.
definitely understand that. I
There's
understand.
something called find. You can use find operation to
And
figure
what is the it's a login, obviously, because
that is login.
the train.
12 add 48. Take care.
Each of these are our nodes, right?
Yes, each of these are our server nodes.
We can
Server
say
nodes.
these are the hash values which you are hashing, but
These are our server. We are storing server nodes over here whenever we want to find. Now the question is, when we say find, is this finding a successor or is this finding a value?
find will find the value. But now the problem is, let's say something is hashed to 20.
Correct.
Now, what you want to do is find the successor of 20.
We don't want to find the successor of 20. We want to find, let's say, the successor of 19, let's just say.
No, we want to find the 21.
Huh.
There's no node called 21 right over here. Where
We
does
don't
it
have to find a 21, na? Because the thing is, this is server over here. When we are basically taking an object and it is going to create a hashed value out of it, it can either create a hash value as 21. If it creates 21, then we need to find a successor of 21. If it's create a value of 20 as well, then we can, if there is a server which exists at 20, then either the values or of that is going to get stored on that. Or if we take a successor of 20, then the successor of 20 does not necessarily have to be 21, right? It can be 23 over here.
I didn't get the question.
No, you guys were discussing, right? What will be the successor of 20? 21 is not here. I'm saying the successor of 20, or let's say 21, will be 23.
Yes.
Correct.
There
So
won't
how,
be there won't be any there won't be any successor for 21 because there's no node called 21 here.
No, that is what I'm trying to then ask you. You told me that there's a implementation which tells
what you do is you find the value which is lower than that value you are searching or the higher than that value. With using find, you'll be able to point that out. So Sunny, find B, I think there's here.
I think so. If I say, let's say you have to find 19, it should. So that's how it will travel and eventually say it will reach 20. Now
it will. So basically, yes, that is what the point is. So it will reach 20, right? Can we try for 21?
Then again, I think it will go the same path.
Then path does not tell us. Correct.
Exact path won't tell you, but it is stored in that order. You can use this, figure out where it
eventually see.
It is not right. It is not stored in that order because it is going to give us 20. Whereas for 21, according to concisely hashing ring, we would be looking at 23.
See, what it will do is it will, for 19 came to this 20.
A second, I'm trying to figure out what is the default set of methods which RedBlack tree returns.
I implement.
See, what I understand is like for a given value of hx, let's say you want to map x. First thing is you find the leaf node, and from that leaf node, either that leaf node will store it or the successor will store it based on the hash value. These are the only
But
two possibilities where the data will be stored.
But in this case, the leaf value would not store. Let's say take an example of 21. The leaf for that will come to up to 20.
That means that 20 is not the node. We have to find the successor of 20. What is the next value in the tree after 20? So that's where the successor problem comes up. And there is a standard algorithm to find the successor of a given node in a binary tree. Like all these trees are binary tree, like whether you talk about RedBlack tree or normal tree. So there's a standard way of finding your successor node of a given leaf node or any node actually. So from a given node to find the successor, you can do it in log n time. That's what they are saying.
And you can modify the search to return either the larger than that item or the smaller than that item, right? Those algorithms are pretty standard. They are available in the STL for most of the languages.
Like you can say
I
that.
just have a quick question. Why can't we directly, instead of finding all those successor things, why can't we find the immediate greater value than the consistent hashed value which came out? So let's just say consistent hashed value came out 21, let's just say. Why can't we directly do, if we do a searching of the immediate next higher value, then that serves the purpose.
You can do that. But that is not the need for having RedBlack tree over here, or the successor is not for adding the value. It is for distributing the ring when the data
redistributing to ensure
when node number 20 goes, where does the data need to go?
Fair enough. So got it. So basically what you are telling, okay, this is not really for
insertion,
because that purpose can be served by any binary tree easily. Yes. What it is here for, to ensure that there is a balancing among the nodes.
Correct.
Got it. Then I got it now. Perfect.
Okay. Cool. So I think this is some history. This is good. Yeah.
Cool.
So shall we quickly summarize it?
Yeah.
Okay. Sunny, go ahead.
Cool. So I think first part is what is consistent hashing. It talks about like mapping a list of objects or values or requests to your underlying storage or servers.
So
now we understand what is consistent hashing. So it started with the issue of web caching, where it talks about caching this Amazon.com as a web page onto your different servers. Now the problem with this kind of approach is like if the number of servers increases, you have to re-cache. If you increase the server, your server needs to be recached onto the new server. So it depends on your caching algorithm. So for that, the simple solution will not work better, but your consistent hashing works much better, where you define all the objects on the ring, and then you also hash the servers on the ring. So all the objects.
Can we show one example why with modulus kind of an operation it will lead to redistribution?
Sure. So if we take an example of modulus, so what it says is like you will map one URL onto your n servers using the modulo. So if the number of servers increases, let's say from 100 to 101, your whole caching strategy changes, as in all the objects mapping will change to some other value. So let's say my key 21 was mapped using modulo 8. The initial value would be modulo 8 will be 5. Now if I change it to 9, the total number of servers, the modulo will change to 3. Maybe. It depends on the actual number, right? So 21 was the example, and then if you change from 8 to 9. Yes, for 21, yes. So that way, so all the
the final destination for all the keys will change if just by addition or removal of a single server.
So all the objects will need to be rehashed and restored, which is a very big operation. So this hashing of just plain modulo n does not work well. So as compared to your simple hashing, there's a consistent hashing approach where your total key space remains hashed using one hash function.
Mm.
And you also hash your total number of servers across the ring. And then keys are hashed based on the position of that key on the ring as compared to the hash server's position on the ring.
Yeah.
Can
So
I
there's
add on
one
something?
there's one key difference over here. In your normal hashing scenario, you do not hash the servers. In this setup, you generate hash for your servers as well.
Correct. And
But in a
then
normal setup, what we basically do, let's say if I have to, can I put it in layman terms? From
It's a
what
key
the
value.
problem?
It is basically you have defined key value. Your
You have
value is
defined
the
a key
server.
value of object and to the server, and that's how you are storing it. So if
Correct.
you have to do, you have to basically scan the whole thing.
Yes.
Yeah.
Perfect.
So here addition of new node just impacts this range, and specifically only this part of the range where it was previously assigned to S0 is now assigned to S3. So at max, only one nth of the ranges are being reassigned.
Yeah, but one key point to note over here, which make things very easier for people to understand, is in the previous approach, the hash value was or the mapping was happening to a single value.
Yeah.
In this case, the mapping is happening based on the range.
Correct.
Every server is allocated a range instead of a single value.
I would say slightly different. I would say that over here, the value is still mapped to a single value, which is basically the hash is returning a single value, but that range is mapped to that server.
So no, so that is a way to define the range. Essentially, you are only allocating the ranges to the servers.
Correct.
But the way you are allocating that is by associating one number from the hash ring and using the other the server ahead of it and behind of it.
Got it.
And the last section talks about how to ensure the equal distribution on the ring, which is by having multiple hash functions for the servers, which hashes multiple values. So as compared to n values, now we have n into number of hash functions values, and then those will ensure the equal distribution.
You'll still have to experiment. This theoretically says that log 2 of n is large enough, but I think you'll still need to experiment it in real life to find what is a reasonable multiplier.
Cool.
Perfect.
I think this is good.
I have a quick question.
Hmm.
So I was just thinking about it. Does the consistent hashing also eliminate a single point of failure? And let me elaborate a bit on it. Okay, I was just thinking, and I want to take your point of view as well on that. So let's say when we did not have a caching, so let's say we have 20 servers, and what we are doing is we are randomly mapping. We are deciding, okay, this data is going to get stored in this particular server, and we obviously have to keep a mapping of that where which object is stored to which server, and it has to be stored somewhere. Right? There's no hashing function involved. There's nothing involved over there. The mapping has to be kept somewhere. If that system breaks, where the mapping is stored, wouldn't it cause everything else to fail? But over here, since it's a proper hashing function, you can have multiple servers which can do a consistent hashing, and it always points to that ring. So is it also removing? Do you guys think it is also removing that single point of failure element from here?
Not all by itself. Only if all the nodes are responsible for distributing the data.
No, all the nodes are responsible for distributing, but nodes are not responsible for distributing.
If you have a single server, central server for defining or deciding where this data would go, then you still have a single point of failure.
you necessarily won't have a single server to decide, right? That is what I'm saying, because we always have an HA for those. Let's say in a normal scenario, where would we store the data, the mapping?
In case of Dynamo, you know, this is distributed across all the nodes.
Correct.
I think it depends on application to application. In Dynamo, all the nodes are responsible for hashing as well.
Hashing as well.
So, but if you talk about load balancer kind of use case, it might be different, where load balancer is doing the routing based hashing and
Many in load balancer is not there is a single point of failure on the routing table.
yeah.
It is not.
Then load balancer is your distributed application where it will have multiple servers at the back end.
And a lot of distributed databases have still this. There would be a one manager kind of a node. That is where your Sunil, what did you use for that? Kafka management. What is that tool called?
Zookeeper kind of.
Zookeeper. That is where Zookeeper distributed config management comes into picture.
Got it. Okay. Super.